In this video, we're going to show how to create welds, model 3D welds in the Autodesk Inventor weld environment. For starters, we're going to start with the fillet weld. So we've already have this model converted to a weldment, and we're going to go ahead and click on the Weld tab. And then we're going to click the fillet command. And you'll get the weld dialog box. And the first thing to note is selection sets. A little bit different than constraints. With constraints, we're used to pick the first face or feature, pick the second feature, you're done with the command. While in the weld environment, you have to manually click between the selection sets because you can make multiple selections in each selection set. So in this case, I'm going to pick the first face, and then I'm going to pick the second face or second set of geometry. And in this case, I'm going to pick that face. And note that it's just putting a bead on this side. Well, we're going to cancel out of that. And then we're going to do the fillet weld again. I want to pick that face. And then I'm going to pick the chain. And you have to pick the chain before clicking the second selection set. You can always unchain it after that. But to be able to chain a face, go ahead and do our second set. Notice how it's picking all the entire outside surface of the tube. And now it's giving you a preview of a weld. You're going to go ahead and put in your leg length and determine how you operate. If you want to put the length of the leg, say the perpendicular edges, or if you want the throat or the height of the weld. Notice you have contours, so depending on how you guys typically weld, or what kind of contour you want on the weld, you can specify that as well. We typically just take the default. Then there's also extents and how to start and stop a weld. And where that comes into play is this hole. So we know we want to put a bolt in here, so we need to make some room for this bolt head. So what we're going to do is we're going to weld all the way around, like it says, but we're going to do a start offset. So we're going to offset that weld a ½ inch from that hole so we have bolt head clearance. And then we'll also do it on the back end. Now where the weld actually starts and stops varies by the parts and varies by the geometry. A lot of the times it will pick off of, say, an origin plane, but in this case we have this whole feature here, and this entire ½ inch leg is bigger than the distance from the edge of our tube to the edge of the hole. So it knows that, and it won't put the bead in there. So now we have a weld bead there. Now I will also note that on the selection sets within the weld environment, sometimes depending on the geometry, if you don't get a preview of a weld, changing the selection sets, flip-flopping them, you make the first one second, the second one first, sometimes will give you a result. Sometimes if you're picking multiple faces, you should go in, and if you're not getting a weld, go in and make it a smaller selection set. Take away some of the faces. Sometimes you can find the piece of geometry that's not letting the weld happen. So slowly pick them one at a time to add them, and you'll see where the weld stops. Or where the weld fails or the preview fails. If you make an error in your selection sets, let's say we go ahead and pick that, and then we pick that by accident and say that. You say, oh, wait, I shouldn't have done that. Or if you fail to flip the selection set up here, if you just hold your control key, you can deselect faces. So then you can proceed to the second set of geometry. Sometimes you have to go in and actually put in a smaller weld leg to get the weld to show up. For instance, say we really did want to weld all the way along this edge, we might have to back that weld off to say 3/16 or to 1/8 of an inch if we truly want to show the weld. And quite often if we run into those instances, we will put the smaller weld in there and then use the annotations, which we'll cover later, to specify the actual size of the weld. Now some of the other welds that it's capable of doing are pretty cool too. So let's say we want to weld this plate to this tube. So we're going to go ahead and do a fillet weld. We're going to pick that face, and then we're going to go and get the second selection set, and we're going to pick that, which you can see it's putting the weld in there. We're going to pick that one. We're going to pick the end of the tube because we want to weld between these two faces. And then also we'll pick this back face. And we're going to include, and I did make one mistake. I picked a wrong face. So here's where you can go in, hit your control button, pick that. I want him to be part of the initial selection set, and now notice how we preview. So even midstream command, you can use the control function to straighten out the faces, because sometimes it can get a little bit confusing. But in this case, with one weld command, I'm getting a weld that goes all the way around that part. So let's go ahead and accept it. I'm going to leave it at the 1/4 inch leg length because that's still what I want. And there is one little caveat here, which is a bit of a wish. We told it to put in a 1/4 inch weld. Well, if you actually go in and measure it, it only measures 0.165. Now my belief of why that happens is because it's when we did the initial first selection set, it filled this weld in, this top weld here, it filled it from the top down. And somewhere in the math it's using the 1/4 inch, but it's not really giving you that accurate weld. So just make note of it that when you say a 1/4 inch weld, you may not necessarily be getting it. So the recommendation is not to have your guys actually measure the weld to see what size the weld is. When we get into the annotations, if we fail to annotate that, your manufacturing should come up and say, hey, we got a missing weld symbol. Okay, don't go in and actually measure the 3D model. So now we're going to move on to multiple partial welds. Essentially, we're going to do multiple welds across multiple parts within one weld feature. And so let's go ahead and get the fillet command. A little bit slow in coming up there, but finally came up. So we're going to go ahead and do a fillet between that. And then we want to do a fillet weld between the edge of all these places. Basically, we want to tie that strap in place. We're kind of making it great. We want to keep that separated. So that weld's a little bit bigger than what I want. We'll actually make it even smaller yet. We'll leave it that big so you guys can see it. So notice that it's doing a full weld across all these legs. And the way to think of this, you can flip direction also. So if you want to go the other direction, notice how the arrow moved to this end. So it's basically starting here and then doing the other welds. If we flip it again, it's starting here and then doing all the welds. The way Inventor treats it is essentially it's doing an extrusion along a path. And it sees this, even though they're separate parts, it sees it as one continuous weld. So with that, I don't want full welds. I just want a stitch weld in the middle. So I'm going to go in and I'm going to say I want that weld 3/8 inches long. Okay. And how often? I'm going to throw this number in there because I know what it is. But the initial offset, we would know we want to offset that 3/16 of an inch. In the offset, we really, at this point, don't need an ending offset. But if we look at this closely, we'll set this back to take that back off. So we know we want to do a 3/16 offset because we only want a 3/8. So we're going to have 3/16, 3/8 a weld, and then 3/16. Well, like I mentioned, this is one continuous weld. And to be able to get that to stitch along each one to where we only have a 3/8 weld, we have to put in a pitch. And doing some playing, you can see if I do 3/4, it gives you a little bit of a goofy weld on these other welds for the start and stop. Well, after some trial and error, I found that 0.8025 is the magic number, so that we end up basically with 3/16 gap at the final end. So keep it in mind that this treats this as one continuous weld. Is where the intermittency gets a little bit goofy, and the easiest thing to do is just do some trial and error. Keep tweaking it until you get it what you want. And that takes care of multiple stitch welds. So now we're going to move on to the groove weld environment. And groove weld is pretty straightforward. And we'll pick our first selection set. And essentially what it's going to do is we want to weld between these two tubes. And what it's going to do is take that end profile, and it's essentially going to extrude it to the other tube. So we're going to pick our second selection set, and we're actually going to pick all three of these faces. And it should extrude to that face. And then the third thing we have to do is pick a direction. And that direction is basically the direction that that weld is going to flow through. So here we can see that it's giving us a nice preview. Go ahead and hit apply, and now I'll put in a really nice groove weld. And you can do this with, say this tube is shorter, you can also do that too. They don't have to be two of the same size tubes. So that's the basic of the groove weld there. Now you can actually, if you want to lay even more weld in there, you can lay multiple welds on top of each other. So we're going to pick that face, that set, and we are going to unchain the second set. And notice how it's building that weld. Now you do get a little bit of funkiness up here in the corners here where they try to blend. It's just something that's just you're going to have to deal with it. Because you think about trying to extrude a triangular profile along a spline along here, and essentially that's what it's doing. To be able to fill in that gap, if you manually had to model that weld to try to get that to do, it's actually quite impressive what it actually even does. So now there's another type of groove weld, and it's basically radial. So we'll go ahead and pick the groove weld. We're going to pick this tube. We're going to pick the ID of the hole. And then instead of just picking a direction, we'll just hit radial fill. And it's giving us a preview there. And there, it just filled that gap in between those parts. Now that might come into play where it's a little more important for, say, an FEA. But I'm going to go in and edit that weld. And I'm going to pick a second set down here. I want to do that hole too. So you can do that. You can do both holes in one shot. And if you want to, like I mentioned, for an FEA to be more accurate, you can go in and pick the weld, kind of like we did on the other groove weld. And we can lay a weld on a weld. And we can also pick multiple sides of that as well. So we can go back to our, so that's the blue selection set is the rectangular tube, so we'll pick that and pick that. And it's previewing it. So now we have a fully welded tube using the radial groove weld. So the next type of weld is a cosmetic weld. And with a cosmetic weld, it's just that. It's more or less for the places you can't get a weld modeled. And to do that, we're going to go into the weld environment. We're going to click Cosmetic and basically say what edge do we want that cosmetic weld on. And then also you want to pick the cross-sectional area, because this will come into play as welds do affect the mass, the physical properties of a model. And even though there won't be a model of this actual weld, it will be calculated if we so choose to. So the essence of a cosmetic weld is just that. It's that weld bead, it measures that length, and it's going to include that in the eye properties. So if we go into eye properties, click the physical tab, and hit update, notice that there is this dialog box here, include cosmetic welds. And if you watch this mask, when I click it, that will change. So it does include it in the mass and in all the other physical properties for this model. It's just there's not a visual model there. So that guy is kind of our last resort when we're trying to place a weld. So earlier I mentioned preparations, the process of preparations. And with the preparations, the way we typically use it is to do a plug weld or a groove weld. So if we go ahead and click the preparations, pretty much it activates these tools, and you can activate a 2D sketch, just like anything in an IPT if you're designing a part within an IPT. So I took the liberty to save a little time and create a groove. So I had a sketch in there, extruded at that length. So what we're going to do is basically put a groove weld or a butt weld in here, or kind of a plug weld, if you will. So once we get done with that preparation, we can return out of it, and then we can go into the welds. And we're going to do a groove weld. So we can pick that face, and we're going to swing it to that face. And as you may have noticed, I click the radial fill button. Sometimes the radial fill will fill in a complete box like this as well, if you choose not to pick a fill direction. So you can either do radial fill, or you can actually pick the direction. So it's going from that face to that face. It's previewing the weld, and there's our nice little butt weld. So it actually gets in there, and you actually get a penetration to it, because then essentially those two parts are flush. And one other thing to note on that is when you do that groove weld, typically there's probably going to be a crown on here because it's a butt weld. You won't have that crown. Now if you want a crown, here's your one other option, kind of your final option to create welds, and that is actually just to make an IPT. And if we open that file, it's just that. It's just a weld that's modeled. The one thing you'll probably want to do to this, though, is go into Tools and Document Settings and Bill of Material Occurrence and change this guy to Phantom. That way he doesn't actually show up in your bill of material. Otherwise, if you call this Weld 1 and you go back to your assembly, you're going to find that that would show up in your bill of material. And we really wouldn't want that guy to show up in a bill of material, unless you actually want to for some reason, but our preference is to set that as Phantom so it's ignored in the bill of material. Another instance of modeling the welds is with this guy. If you want to do two rounds together, about the only way to do that is to actually go in and create an IPT. So we create an IPT within this model, or within this assembly, and then we actually patterned it to get both ends. But if we open that up, we essentially just model the weld. Again, we set the bottom occurrence to Phantom so it does not show up in a bill of material. Then one last little trick in terms of welds is to wrap the welds around the end of a part. And it's probably not real intuitive, but you can actually use the ends of the beads to generate a weld. So in this case, we're going to go ahead and pick that bottom surface. We're going to change our selection set to the second one. We're going to pick that, that, and that. And notice how that gives you a nice pretty weld. If you did not pick the welds, you would just end up with this kind of ugly guy. And that's not too accurate. So just a little tip that you can use the faces on the ends of a weld to generate welds also. The ends of the welds can be part of your selection set. This pretty much concludes the video on the weld features themselves and the little tidbits and tricks to make some of these things happen. We'll follow up with another video on how to detail them, get them onto your prints, and how to do the 3D annotation.